Okay, cool. Thanks, Gudni. I am looking forward to hearing your thoughts on the NSEM Data Class. I think this stuff is going to be quite useful to bring down a level. The other stuff I would like to briefly run over are just some of the properties changes and some stuff that I would like to pull into dev that'll require everybody to update their properties and also give you a bit of an idea of like why we're doing that. And yeah, so that'll take a couple minutes at the end, but with that, I will give you the wheel.
Yeah, just on that, it would be really, really nice to get a bit of more of intro into properties.
Yeah, I've asked Franklin, and he's game to give us a talk at some point, so hopefully even before the holidays.
Oh, that would be really nice.
Yeah.
Because I've started looking into, there's some real power.
Yeah.
But it would be nice to kind of get into it a little bit better.
Yeah, I'll see if he's game to do next week. If not, I'll give like an overview of my understanding.
That would be fun.
So, yeah.
So yeah, I was going to talk to you guys a little bit about the data class, and specifically just talk about my experience, my motivation for using it, and kind of what I've been doing, kind of to update it and make it more usable for me. But I'm really trying to keep the whole SimPEG sphere in mind when I do that. So yeah, not worry, I only have 5 minutes. Yeah, anyway, so why a data class? At least from my perspective, it's a kind of a light addition to all the other internals of SimPEG. I mean, kind of dealing with the survey and dealing with vectors. Like it's a lot of moving parts, so the data kind of just takes care of that when you're dealing with data. And having it a class rather than having it kind of like a vector and kind of keeping it somehow associated with the survey, I mean, it's just, you just have it in one container, and it's object-oriented. It's really easy to add things. It's really easy to check for whether you have a data class. So if you're writing a function, you just check it. I mean, with properties, it's like a one-liner. So it just makes, mind you, though that would have to be a class. But anyway, it's just, it makes everything so much easier. You can build in stuff. It's just, and I mean, especially in the natural source kind of case where the data is actually quite involved in terms of where you go from, where and how you go from the fields, what you calculate, to what the data is. And then kind of what you want to do with the data, kind of how you want to visualize it, how you want to deal with it. Like you add on layers of complications. So it's just nice to add a layer of code to kind of correspond to that. And kind of an important factor for me is that it then connects to real data. I mean, if you talk to somebody that works like a practitioner, he works with data. Like for him to work with a source and a receiver, put it into a survey, it's just, they can get there, but it's just, if they go to it through a data class, yeah, I mean, and you just lead them along, and that's just much easier. It's a much easier transition. And I mean, in an essence, I mean, data will have to have that spatial information to be able to be data. So kind of keeping it all together in a well-contained, kind of scalable, extendable packages, kind of my motivation for a lot of this. So just to give a super brief overview, I'll actually show you the code. It is very minimalistic. But so kind of how the data currently works is that it's a class and you call it and you index it by a source and receiver pair. So in some sense, it's somewhat similar to the fields class, where you kind of have that nice indexing to kind of access your data or your information, I guess. And the current state of the code is that we have something that is kind of called the base class, which is just kind of the container that contains the data and has that kind of source receiver indexing, checking. And then on top of that, there is a standard deviation and a floor property on the data class that are also a base data that inherit or actually are a base data class. So
they're classes?
Yeah, so they're classes. So they have, it was just, I'm not saying that this is necessarily how we want to do it,
okay.
But for me, it was just easier because then I could actually take the old data class, rename it base data, and then just add a data class that just inherits correctly.
Okay, I'm curious to see this.
Yeah, so at least it seems to be working. I'm fully aware of that there are probably better ways to kind of handle this, but it's working. And then there is a survey object that gets built with the data into the data class, and then you'll have methods, and I will kind of show you some of the methods that I have.
Sorry, when you say the survey object is built into the data class, is it paired, or is there like a util that can spin a survey out of it?
I mean, so it depends where you're coming from. If you're coming from a data file into SimPEG and you read it into data class,
yeah,
you would generate the survey from the data file.
Okay, but the survey is not a property. Is it a property of the data?
No, it's just,
okay.
It just has a property that is a survey.
Okay, cool.
So there's no pairing, there's nothing like that. But I mean, the survey, I think that is probably something we should look into to have that kind of a little bit more rigorous, because you need to make sure that the survey and the data match.
Yeah.
So, I mean, if you make sure of that when you build it, you're okay, but there is a potential for corruption. But this is how it was. So this is the code. So this is the SimPEG. So in the main SimPEG, in the survey file, there's a base data class currently. And it has the keys and kind of, it checks that the keys and the receiver match and our our properties or our items in the source list and then in the receiver list. And then you have the sat item. You have the get item that then kind of checks. And then you have two methods in the base class that are toVector and fromVector. So these are kind of just speed the utilities. So if you have a vector that you know matches, it kind of just takes care of it for you. Then this is the definition of the actual data class. The base data, not the base, but the data class in SimPEG. Yeah, so this is how I did it.
Is there, and this is perhaps more detailed, but the standard deviation in the floor, do they have methods on them?
I mean, there's nothing that, I think there's nothing in this that wouldn't allow you to. You would be allowed to do that. I don't think, I mean, they have the same methods as the base, they have the base class methods.
Okay.
Currently, they do not.
Right, but they would still have toVec, fromVec, and you can index them like you're expecting.
Yeah, yeah. So that was kind of what I was after.
Okay.
So, I mean, we've had several conversations about this. Sorry. I'm trying to show you guys. And there is an open issue using the data class from January, and I'm essentially just based it on that. I did the kind of simplest thing that I could think of. So I based it on your comment.
Okay.
From September. So it's a first pass, and but I mean, I think having these properties built into the data class is super powerful.
Yeah.
And useful. So we can, I guess, have another conversation about that. So, kind of from my perspective, again, like what I want from the data class is an input-output, kind of an ease of doing that, like an easy way to do that. And again, it's also, I find it important to be able to import the data and then kind of just be certain that the data has been checked, that there's some sort of error checking, and it will work within the SimPEG framework. And then having tools to kind of view the data, plot, and analyze is also important. That being able to just build them on top of the class and call them directly from the object is super nice. And then having something to manipulate the data. And I mean, you often need to filter out points, rotate data in the natural source case, assign uncertainties, and other things that are better suited as methods, or at least functions that only work on that kind of work on a very well-defined structure. And then I'm sure that there are more things that we would like to have kind of for the data classes. I mean, I can think of being able to share between different data would be nice. Having the SimPEG data and being able to define a method that then can be just kind of interchangeably used.
Yeah. I mean, I guess I would be careful what we say, what do we want in the data class versus like interface to, because a lot of the stuff I would say is like, I mean, we have the data class and probably want to keep that actually like a fairly lightweight thing. And then the processing side of things is like, it should interface to it.
Sure. That's just,
yeah.
I chose a word, yes. Yeah. But I agree. I mean, and a lot of my development or most of my code are written as functions. But I just found that having a class to check, I'm like, okay, it is a data class. I just don't need to worry about it being something else.
So Gudni, is this a data class a general data class or only for natural source?
It's a general data class, and then I've just built my own that inherits from the data class. So I'll maybe leave this one till later. So I just quickly wanted to show you guys.
Did you have to change anything in the inverse problem code, or like the data misfit?
No, I haven't touched the internal. I just now use just 2-vector.
Oh, okay. Fair enough.
I mean, that is another conversation that might be nice to have.
Yeah.
But at least I'm comfortable and confident when I build my inversion object that my vector and my survey should match.
Okay.
I think there's value in doing both or either. So just to show you guys the natural source data class. So the the truth. I mean, in essence, it's just initiating the base class. And I've currently added two methods to it, one class method that read in legacy structured data arrays that I used when I started using Python. There are kind of like they're essentially a table, and are indexed by the name of the column. So it's just it was a convenient way for me to transition from MATLAB, because I've been using structures very similar to that in MATLAB. So these are just kind of legacy functions that I still have and I still use quite a bit. But kind of what I just wanted to show you further were just some actual examples. So here I'm just actually kind of gathering the structured data files that I have modeled previously, and then using my class method to return a data object. Yeah, and then so that will contain all the data. There's nothing been kind of done to it. And then in the next block, I am just sorting the structured array and only picking out the frequency, the location, and the off-diagonal components of the impedance tensor. And I mean, yeah. So from there, in this case, I just want to assign uncertainties. So I've built a util function that extracts data information. So it was just a convenient method for me to return the observed data, the frequencies that those data correspond to, and then the type of data that those, the type of data.
So if you just wanted to use, let's say, ZXY, you can just extract just the ZXY.
Yeah, and then I can just extract ZXY.
So you just don't put anything else in there, you leave the ZYX blank.
Yeah, so I would just take that out. So, I mean, and this is something that I would want to mitigate or like put into the actual data class, kind of move away from structured arrays. But
It's good.
yeah, but legacy is
Stepping stones.
yeah. And I mean, there's nothing that like this could be built into a method of the class, or a function that works on the class. And here I'm just kind of picking out, finding the indexes finding indexes of the off. I guess in this case I find off and on diagonal. And then I just assign the standard deviation of 5%. And then I deal with the floor. In this case I'm doing a kind of a mean of all the data for for each of the frequencies. To do that, I can sort through and pick them out, and then assign that to the floor object. And then in this case, I'm just showing, so for the inversion to get WD, I call the eval method of the data class to evaluate the uncertainty.
Wait, sorry, that is the uncertainty?
Yeah.
You're evaluating the uncertainty. So empty obs is actually, because I would have expected that to eval data or something like that.
We probably need to rethink about the naming.
Yeah.
but that is what we wrote in that issue, so that's just what I wrote. We called it eval
Okay.
to get the eval and return standard deviation times the absolute of the data plus the forward. So,
But I guess that would be, yeah, that's fair.
yeah.
That was, yeah, agreed. That should be rethought.
Yeah, we should, I mean, like, I look at this as just kind of showing how I've been doing it and kind of getting it out there that there actually is a data class and that it is useful and we should be thinking about using it because it is nice for so many reasons. So here I have written a viewer for the natural source data. So when I call it, it just gives me this nice location plot. But I've added in functionality to it. I need to do. Have a pop-up error. So in that case, I hadn't defined the standard deviation and the floor, so it couldn't plot the error bars. But so here I have, and now it will pop up a window, just another matplotlib window. In this case, this is work in progress. So just give me the error bars, give me the plot, and then I can now interact with the data. So when I click, it will update.
So what do you, is that all matplotlib?
That's all matplotlib.
That's cool.
Also, the two figures are linked there.
Yeah, so they're linked through the class. There's just a property that I now have to write as a property and put an observe function on it. But yeah, it's essentially that. I just have a location.
So are they able to create another panel or figure showing, like, for example, a line profile or something? Or map, or I don't know.
I mean, there's not as of now, no.
Okay.
But there is.
Possible. It's possible.
Yeah, there's nothing. I mean, you just would have to write it.
And you're basically linking multiple figures.
Yeah, so
just two.
I have that. And that's actually thanks to you, because you gave me that idea. I've been struggling with how to kind of set it up. But yeah, just set it up as a list.
Yeah, that's fine. I just want to know the possibility. Right?
Yeah, so, I mean, I'll show you guys. So this is just assigning to the whole object. So this contains both empty and tipper data. Again, here. So by default, I get it to plot both the impedance and the tipper. And again, this is fully updatable. This is a large data set.
What's the yellow?
The yellow dot here is just the location that I've selected.
Oh, I mean.
Here. So that's the YY component.
Oh, just different component.
Yeah.
You can't call it. Okay.
I mean, I need to. It's on the agenda to add the legend.
Okay.
So yeah, and currently, so kind of just, so how I built it Again, just show you quickly the code. The two main data classes. So I have something.
That's a cool idea.
The default.
Yeah, just default colors.
Yes, that is really important. But they're still, you can override them. So I have this default, and this is kind of made by my preference of colors. But then I wrote out this validate kvargs. So if you give it other arguments that correspond to kind of this comp plot kvarg dictionary, it will validate those and replace. So if you give them, it will add them into the keyword argument that you pass to the plotting function.
Okay.
So
have you looked at the the view stuff, the plotting that's in there? Just the way we pass keyword arguments.
I did look at that, yes, but then I'm not entirely sure if I implemented it the same way.
Okay.
But that is something that I think. So I kind of, the approach that I took to this was that I wanted to take old code and move it one step further.
Yeah.
So I would say it's half the way into SimPEG.
Okay.
But I mean, I know that there is somewhere like a validate kvargs somewhere. I was just,
yeah, that's right.
I'll just write something quickly that works for me, and then hopefully I made it general enough that at the point when we want to change that, we just change it.
Yeah, no, that's good.
And that is very much my approach with building these tools. So in this case, the plot utils contains a lot of classes, and then some kind of hidden utility functions that kind of do very specific things for the plots. I might move these somewhere else in the long run, but so I have this base data data NSEM plots that kind of just sets up the structure that I want, and it does inherits from properties, and it has properties. So it has a figure property, and it has the axis property, which are just matplotlib figure and axis properties. I guess lists or objects. And then I implemented something that I call setup and a draw function, and then a clean axis. Again, naming convention can be changed, but kind of these functions, I'm hoping are kind of self-explanatory. So if I show you the two classes that then inherit from this base class, I have the taper amplitude station plot, which has a setup function where it actually makes the figure and the axis, and sets some default parameters that I want for that particular figure and the axis. So I do set I invert the axis. I set up the x scale to be log, so the frequency, and then one of the y scales is log as well, and set the names. Then in the draw function, that is where I then populate those axes with the things that I want to plot. And I have some additional arguments here that I don't pass in one sense and pass in the other. And here in order to be able to plot multiple, I pass it a list of data. and then call the functions, and I call the first one with error bars. So by default, I need to have error bars, and then I call the second one without error bars. And that allows me to plot up and kind of compare. So if I have predicted data, I can just plot that. And you notice here that when I plot, I'm actually calling the data, I'm calling a method of the data. But I mean, in the definition, I didn't define those. Rather, I have another class here that I call data NSEM plot functions. That where I've written up these plot functions that I want to work on the object, on the data object.
So then the NSEM Data Class is inheriting both the base data and then your specific plotting functions?
Yes.
Okay.
Yes, it does. So, and I mean, I just find that after I learned how to do that, that's just a really nice way to kind of keep your class. I mean, the data class kind of simple, but then add onto it just kind of what you need. So.
The other thing I noticed, because we can, how are you using UIDs? You were assigning UIDs. Are you validating against those?
I'm not doing any validation.
Okay. That's fair. It's because I absolutely agree that that's something that we should put in there, is like assigning UIDs and checking.
I am assuming that it happens in the base data class.
Okay.
That Rowan wrote 3 years ago or something.
Okay.
That works really well.
Yeah.
So if you give it a receiver that isn't a receiver of your survey,
yeah,
it will yell at you and
okay.
give you an error.
Yeah.
And I've done that. So I mean, there are some caveats in that. But yeah, and I mean, the data class should mature.
Yeah.
Which it really hasn't until now.
Yeah.
And I mean, it didn't really mature. It just a little moved around.
Yeah. No, absolutely.
So yeah, so here I just have an assortment of functions or methods in this case that I can then just call from the object. Okay. So just kind of depend on in the example that I've shown you. Some data. So here I can just I have my tipper data object, and again, there's no checked, like there should be properties there that just kind of tell you, oh, it's this. But here I can call the functions, and it will. I mean, I can call the apparatus, but I mean, obviously there's no apparatus data, so it should return an error, and it will eventually. But it plots the function, and I set it up with the some default parameters of the window, so to kind of make it easier to call. And again, same with the impedance. I have all the plots, and I'm just calling it by location, and here just telling it that I want error bars. And again, yeah, and then the interactive viewers. So
yeah, the interactive only works if you pop the plotter. Is that right?
it should work inline.
Yeah.
But it gets just because it's like 3 other steps that need to. It gets really slow.
Okay.
And I think with the newest Matplotlib or Jupyter, you can't mix in your notebook. Right? If I've done inline, I can only do inline. So.
Okay. So that plots this guy. Nice.
So here I just make the view again. And again, things that I wanted to show you guys is then, so in this case, I have some additional information, some topo and some geology information in shape files for this particular problem. And so it's obviously not without That's why the restart button in the notebook is pretty awesome.
That's okay, we can.
Sure. Yeah, there's some. Okay. Thanks.
So what do you think, I guess, are the next steps to get that down to SimPEG? Like my first pass suggestion would be to maybe like isolate the changes to the data class, and then if you could do a pull request, and then that's something that we could iterate on and like think through.
Sure. I mean, I'm easygoing. I mean, yeah.
Because I think that might be sort of the best way to.
I honestly think. I mean, it is what it is. It is a util, most of it still.
Yeah.
So I personally feel that the whole thing can be pushed down.
Yeah.
And just iterate it on. I think it would be valuable for other people to just have everything.
Yeah.
And I think it. Like I point out here in the last slide is that kind of more use of the data class would be very useful for the community.
Yep.
So yeah, so I'm more than happy to try to get it into a pull request. I think I already have a pull request on the brands that I'm into NSEM.
Okay, yeah. Because if you could, because I'm sure there's other stuff.
There actually isn't a lot of other stuff.
Okay, perfect.
Except the logger class.
Okay.
But I can take that out.
That might be good, yeah, if we can sort of isolate those changes. That'd be awesome. This is really nice, Gudni. I'm excited to see this come in and make it a lot more usable.
Yeah, so just to kind of briefly finish.
Yeah.
So I think, making it into something that we use in SimPEG would be great. And figuring out kind of ways to make it a little bit more, making the data classes a little bit more custom.
Yeah.
Having methods that kind of make sense for each data, because they don't all necessarily, they shouldn't be the same. Or there should be multiple ways of dealing with it.
Yeah,
so
absolutely.
in the MT case, for example, like having a station index or a location index or both, or would be something to move forward on.
Yeah.
But that's a bigger conversation.
Absolutely. Cool. Thanks, Gudni. Do you guys have questions or things you want to bring up with Gudni? No?
Not super well
Play
formed
around
right
with
now, I'm sure.
Sorry?
Not super well formed thoughts at the moment, but.
Well, we can maybe get like a simple example that we can post with the notes today.
Sure.
And be something to play around with. The other thing I'd like to quickly run by you guys, I might steal the cord and share my screen if you're good with that, is the properties stuff that's coming in. So this is a pretty base level change. It shouldn't actually change too many things that you're currently using, other than
You'll have to pick your screen.
I think it's just screen sharing.
Yeah, but you have to pick it up.
No, it should be the whole thing. If you look at yours, I'm sharing the whole thing.
Oh, sorry.
So if we go to SimPEG, so this pull request here, I would like to get this into dev. So what this does is this now is updated to interface with properties that is live. So properties basically does strong typing in Python, which means, like if you're expecting a float, for instance, we can specify that you're expecting a float, make sure it's documented, and then also put some validation on that. For instance, if like conductivity should always be positive. We can have it check that an error before you actually start doing anything with properties. It also does serialization, which means basically taking your objects and saving them in a sane way. So like Gudni's done a lot of that with pickling, but we can also do that to JSON or to HDF5 or like whatever file format you want. And so properties is a nice way to take care of that.
So would it be a way to, like, for example, if you have an inversion result, you would save this inversion result model through properties?
Eventually, yes. Right now, still, I would use the inversion directive that saves that.
Okay.
But yes, once we sort of get properties like injected into all of SimPEG, then absolutely, it'll be a lot easier to save things. So once I merge this, if you into whatever branch you're on, you will need to update your properties library. So just like pip install upgrade properties.
So like we put that in there, and whatever branch we are on, we create a pull request from there to the branch. For example, if we work on from my library, probably on this IP there,
Yeah.
merge that into
Yeah.
okay.
Yeah. And that'll get those changes up there. Yeah. And we'll see if Franklin can talk next week. If not, I'll try and give a bit of an overview and I'll maybe run it by him first. Because I've dabbled in it and there's some really cool stuff. I'm not an expert at it by any means. But yeah, it would be good to do. So we'll do that. And then what I would like to do is get a pull request of dev down to master started. There's going to be a pretty serious set of release notes that are needed. Dev is way ahead of master at this point, like so far ahead. It's a bit ridiculous.
Some stuff too.
Yeah, there's a few non-backwards compatible things. It shouldn't be too major, but mappings will be one. And so what the trajectory there should be is that I'll generate a set of release notes and circulate that to everybody. And if there's anything in there that I have missed, I'll get you to add it because it's important that we communicate what we're changing. So that would be great if I could get everybody's input on that. So cool.
Yep.
Anything else you guys want to go over, things that have come up this week?
So it seems like your data class, there's one portion of it where you're using that read-in function that you created to read in your file that you used wherever. It has all of these headings that tell you what your columns are, right? You're reading it in from like this structure type thing.
Yeah.
That's kind of like just putting it into a database of some sort, right? And you can have anything you want to in that database. And then you can like easily write get functions that'll extract specific bits of data kind of from this bigger database that you created.
So from my data class, sure.
So does your data class like contain this little, I don't know what you like, a database, or it contains this full, does it actually contain this full object that contains all of your data? And then you're just going back to that and you're pulling out individual pieces that you want?
No. Currently, like it's read into the data class from that structure library, for example.
Okay.
So I mean, I mean, I started doing that like essentially when I started my master's in 2009.
Yeah.
Like when I started developing code to try to have a uniform data thing, just so that I could write functions for that, like plotting and dealing with and writing to different formats, reading in from different formats.
Yeah.
And then if I got a different data set, a different data file, I mean, the EDI standard for empty data is notoriously non-standardized. So like I get a collection of EDI files and they are internally not the same.
Yeah.
So I need to be able to read them differently. So just from development of utilities, it's so much easier. And my motivation now is that structured arrays are great, but I needed a class. And SimPEG has a class. It's a different class, but I'm better off writing that function. So for example, I have an EDI utility that reads in the standardized EDI files. And currently when I read them, I read from the EDI to a struct array, and then from the struct array into the data. But the nice thing about that then, so then when I do the inversion, when I want to do the inversion, I've already had the survey. Because I need the survey for the data class. It's just, it's a win-win. And I'm as certain as I know that my reading function is correct, that the data and the survey match.
Yeah.
So in that sense, it's very useful. I do find the source Rx indexing cumbersome. That's why I still use the structured array quite a bit.
Yeah.
But I think that can be changed with like a couple of lines, another for loop or another if statement in the actual base class, where you could just index by a different object. And I mean, we've talked about adding in like a location object.
Something like that, yeah.
Or like a sum object, because I mean, a lot of the conversation that I've had with people that are kind of looking into the natural source code is that they find the source receiver philosophy confusing. And it is. Because also what we call receivers aren't really receivers in the definition of most people. We think of receiver as something that we use for the inversion to invert. So kind of like a thing, but then not really, because we can have multiple locations. So it's like when you know it's okay, but if you're trying to explain it, I mean it's not an easy explanation to do. But then again, it's a very effective way to do it, and it serves a really good purpose. So in some ways, I feel like with the data, adding a little bit more kind of a higher level of interface to the data, that then you just, when you do MVKC, like it just knows what to do. When you make your vector object your data class for your immersion, yeah, you just know. I mean, even giving the data as a data class, sure, but at the same time, I mean that's just not how we necessarily think about it.
Yeah.
But at the same time, that's kind of nice. But that could be kind of on a layer on top of kind of what we currently have. But yeah. But I mean, look at the data class.
Yeah, if you can generate a pull request so that it's and just circulate that on Slack, and we can all sort of take a look and give it some thought, that'd be awesome. That'd be awesome. Cool. Okay. Well, I think we can wrap up, and if we want to keep chatting, sure can. Thanks, Gudni. That was really cool.
My pleasure.